Standard algorithms are broken up into two categories, searching and sorting. We're going to look here at searching and the most basic search, which is a linear search. This is something that you would probably execute, say you're at the cricket and you're trying to find or locate a friend that was wearing a red top. You would start with the first dial and the first person. You would make a comparison whether that was your friend with the red top, and you would progress through to the next person and continue until you found the person you're looking for with a red top, or you got to the end of the aisle. Now that's what's known as a linear search. So what we're going to try and do is to look at how the logic behind a linear search could be applied to that of a computer via an algorithm. Now, searching and sorting themselves, these standard algorithms, are all based around the use of an array. And what we know about an array is a data structure, and obviously what we can see here is a single dimensional array. It's characterized by its indexes. So each element of the array has its own specific index, and that's how we refer to the element of the array, and there's obviously information that can be stored within that. So we've got 1 to 6 elements of our array, and they're the indexes. And the first thing we're going to do is populate the array with some people's names. So obviously index 1 has John stored within it. Now in order to perform a linear search we need a bit more. We need a search item. So our search item is Tom, and search item is often a variable because you can search for a range of different aspects. And the other thing that we also need is index. And index is often the first element of the array, which is 1. So what this causes to happen is for a pointer to stay on that first index or the first element of the array. Now we want some form of comparison, and this would obviously probably be done via an if statement. So we want something like if array index 1, which we know is John, equals Tom, then we want something to happen saying that the search item is found. Otherwise, we want something else to happen. So obviously we can see here John does not equal Tom, so we're looking at what will happen if that doesn't occur. With a linear search, what it does is it increments the index. So index equals index plus 1. So if we add 1 to that index, what it does cause is the pointer to then shift to the second element of the array. We'd want this in the form of a repetition. We want this to continually repeat until either we get to the end of the array or the search item Tom has been located. So this repetition will occur, and obviously we haven't found Tom, and we're not at the end of the array, so we'll continue the comparison again by this repetition. So we'll say if Frank equals Tom, no it doesn't, then we're going to increment our index. So index equals index plus 1. So if we add 1 to that index, it goes to 3. It shifts the pointer to Greg. Once again, haven't found Tom, not at the end of the array. We do our comparison. Greg doesn't equal Tom, increment our index. Goes to now 4. Once again, haven't found Tom, not at the end of the array. Does Chris equal Tom? No, it doesn't. Increment our index to 5. Now the next thing, does Tom equal Tom? Yes it does. Now this is the first time we're going down the different path, the binary selection statement, so we're obviously going to flag that Tom has been found, and this should cause our repetition structure to cease for us to really exit the loop. So obviously we've found Tom, end the loop, that's it. So that's how a linear search works. It's very simple in which to construct and to identify, and it was used in probably the first constructions of internet search engines, but obviously it has some major limitations, and one of those is if you have a large amount of elements within your array, so say you had 1 million indexes or elements within your array, and the element that you're searching for was the last one, or towards the end there, it becomes a very time-consuming search. So it's probably not that efficient if you have lots and lots of information stored that you're trying to locate. So that's the linear search.